Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function f and it is 5x cubed minus 3. We have to find limit as x approaches to infinity of a different function h of x, if possible. And what is h? There are three different expressions for h. The first one is h of x is f of x over x squared. Second, hx is f of x over x cubed. And the third, hx is fx over x to the 4. So let's start with the first one. So we have to evaluate limit as x approaches infinity of h of x, so of f of x over x squared. And write down the expression for f of x first. So this is the limit of 5x cubed minus 3 over x squared. So this is the function whose limit we have to evaluate. Now how do we do that? Notice that since the denominator just has one expression, just x squared, we can first simplify this entire expression and divide each term of the numerator by x squared first. So we can split it into 5x cubed over x squared minus 3 over x squared. And then simplify further. See, the first term you can cancel out some x because we have x cubed in the numerator and x squared in the denominator. So this is just 5x. But the second expression, there is nothing to simplify, so you just leave it as 3 over x squared. And now we have to evaluate the limit. So you can again think of that this is the sum of two different functions and you are going to evaluate the limit of each one separately. So we will have limit of 5x as x approaches to infinity minus limit of 3 over x squared as x approaches to infinity. Now let's think about it. What does it mean by x is approaching to infinity? So for the first one, x is approaching to infinity means x is getting bigger and bigger and bigger. It's taking large values. And our function is 5x. So the numerator of the function, since there is no denominator, it's getting bigger as well because x is getting big, so 5x will also get big, which means the function is increasing without bound, which means that this is approaching to infinity because increasing without bound means that. On the other hand, the second function, the denominator of the function will be getting bigger and therefore the entire function will be getting smaller. And so this is just 0. And this means that the limit is infinity. Okay? Now, let's move on to the second expression for h of x, and it is fx over x cubed. We start exactly the same way. Take the limit of f of x over x cubed and write down the expression for f, which is 5x cubed minus 3, and that divided by x cubed. Now let's try the exact same thing. First, simplify the expression for the function by dividing both terms in the numerator by x cubed. So we'll have 5x cubed over x cubed minus 3 over x cubed. Let's see if we can simplify further. Notice that the first term you have x cube divided by x cube, so we can cancel and we just get 5. And second term remains as it is. Now again we have sum of two different functions or difference of two functions, and you can split it into two limits. So it is limit of 5 minus limit of 3 over x cube. Now recall that 5 is just a constant function and limit of a constant is constant. So this limit is just 5. And for the second expression is 3 over x cube as x goes to infinity. So the denominator is getting large, so the entire thing is getting small, which means this limit is approaching to 0. And so the answer is 5. Now, let's move on to the last part of this problem. And here the expression for h is fx over x to the 4th. We start the same way as the first two. So we have to evaluate limit as x approaches to infinity, fx over x to the 4th, which means this is the limit of function is 5x cubed minus 3 over x to the 4th. So let's simplify first, similar to the first two part. So we can divide each term in the numerator by x to the 4th. So first we get 5x cubed over x to the 4th. So this one divided by x to the 4th. And then minus, we have 3 over x to the 4th. Let's simplify further. Notice that the first term, we have x cubed in the top, x to the 4th in the bottom. So there is an extra x in the denominator. So you get 5 over x. And the second one remains as it is. Again, rewrite this as a difference of two limits, limit of 5 over x minus limit of 3 over x to the 4th. All right, now let's think about it one more time. X is approaching to infinity, so x is getting bigger. This first expression, the denominator is getting big, so the entire thing is getting small, which means in turn that this limit is 0. For the second expression, exact same thing is happening. Denominator is getting big, entire thing getting small. So for this part, our limit is 0. And that concludes this problem. Thank you.